Hello YouTube viewers, welcome to my channel Science and Technology. In today's show, Future Friday, we're going to talk about why fast charging is destroying EV adoption. So let's dive deep into it. So first, we have to establish some timeline so you can understand what we are actually talking about. So first iPhone was released in June 2007, this puppy. So that was the first iPhone, and I am reasonably sure I do not have to explain this changed everything. Everything existed that existed on this in some way or another form, one way or the another existed. He just figured out that why not have a love child from all of them. So that did work. And I'm pretty sure I do not have to amplify the aspect that it changed computation forever. Basically, we literally are reaching a point where generations of kids will be born who will never buy basically desktop. And there is a very good chance they might not even buy, laptops. Like that's happening. Like Amazon's is reaching data point is reaching that more and more people are doing shopping in freaking mobile phone rather than their browser or laptops or tablets or things of this nature. So things are changing. So fundamentally, this was what we call a paradigm shift. It happened and nothing was same ever again. So boom, that's a successful transition. Second, the first big event that people talk about when they are talking about electric vehicle is first Tesla Roadster that was released in 2008. Now, be mindful, before this, electric vehicle have existed long ago. They existed before fuel combustion vehicle. And again, the sole reason because of batteries improvement, especially lead acid and its surge capacity, as in like how much oomph it can dump, starter motor became a thing. Because of starter motor, internal combustion engine became a normal thing. So electric was there, then it took a back seat, then it came front and center. So what was different with this? Use of 18650 lithium ion cell. Now be mindful, lithium ion was very new at this point in time. They were just patent was granted in 1990s and mass production just began. So this was quite early on. And again, that was his genius that he literally picked up a phone, called Panasonic. Is like, bro, you are making 18650. Just give a boatload of us. So that was the battery, and the frame chassis was from Lotus. So this was a very big launch. Now again, you may not consider it was like as big as iPhone, but again, in terms of EV, this was very big. So, and it flat out first time ever created a perception that there could be a future where EV is the only thing. Like flat out, we will replace ICE. Not just like, oh, this is a gimmick that you can do, or like a golf cart was always been an electric system for a very long time. So it's not like, oh, how? No, it's like we always had it. It's just that this created a scenario where in principle, people started to believe that once we have enough technology that we can actually replace ICE, meaning before this was not acceptable. This was not even imaginable, where you're gonna have like a whole shipyard full of cars and not a single of them will consume a fuel. All of them would be electric. This was not imaginable. Same way world without smartphone was not imaginable before this. Same way. So that was the dream, that EV will allow us to replace combustion permanently. So that was the dream. What is the reality? Well, reality is EV made a lot of splash. Like if you follow the news from 2010 to 2015, every Tom, Dick and Harry, as in like almost 200 countries on the planet and almost 17 to 18 top countries from population wise were making claims that they're gonna go EV and all that. It's awesome, it's the future and blah, blah, blah. A lot of splash, like whoa. But here's the deal. If you want to calculate it realistically, did it had an impact? Because again, enough time, 18 years have passed. So did it had enough time, material impact? Answer, no, zero. Like you cannot even detect it. If you are an alien observing Earth from, remote sensing satellites, you will not notice that electric cars have happened. Because it's fundamentally all bark, no bite. It's almost like the same thing. Because tech is not ready for full transition. Yes, we basically forced prematurely. Like this was a very bad case of premature technology deployment. It backfired horrendously. And one question would be, how do I know or you know that this has happened, like or transition has not happened? Because again, if you read news, you'll be like, oh, this is happening. But same way you can figure things out by looking at the source. So source is oil, right? That what would you expect if electric vehicles are selling so much? And because again, you and I do not have a common understanding of millions of units sold. But to give you a context, certain manufacturers in India are so big, and including Ford also, that is in USA, and certain manufacturers in China, they are so big, all these things combined, they're so big that all the EV sales would be equivalent to their poor performing models. Like again, you and I do not deal with this sort of number, and number after a certain scale does not make logical sense to us. So how do we clarify all the noise? Well, look into oil consumption, as simple as that. So this is the graph from 2005 to 2025, and you can see it's a straight line up, straight. And there was a little bit of dip, 2008 market crisis, so like there was a little bit of dip. So 85 million barrels were being drunk almost per day. So, and then currently, as in 2024, 103 barrel was there. 2025 is not completed yet, so that data is not complete yet. And the lowest we have reached is pandemic. Aliens will detect that pandemic happened, because pandemic dropped that number to 91. So this is not happening. This is not changing. Why is that? Well, again, electric is not there yet. It's premature technology. And there are three fundamental aspects of it that is weak. Even if you solve one of them with magic technology, it will not work. So three things are battery, grid, and manufacturing. Now, I have the luxury of working with very smart people, and some of them are working on quantum capacitors. And if assuming, just cross your fingers and assume that it works, battery problem solved. But here's the deal, still will not happen. As in, like, even if you have magical battery, the grid will be the weak link. So let's dive deep into it. Why the heck that, like, all the dreams, this did not came down? And again, every country wants to go into EV. If you especially look into larger population like India, China, USA, Brazil, Mexico, you look at through like population wise, all of them want to go to electric, simply because nobody wants to deal with oil. As in Indians, we do not want to, like, hey, Russia, can you give us oil? Hey, Venezuela, can you give us oil? Hey, OPEC, can you give us oil? We do not want to do that. No country wants to do that. So people want to do it, then why the heck it did not happen? So that's the reality. First reality is this. Another aspect, grid is just not there. So let's quantify that. So primary reason of that is TCO, what we call total cost of ownership. Now, going full EV was the biggest mistake we could have done. Like, that was the aspect of premature. That technology was not there yet where it could have been like battery we done. Like, basically we have not reached quantum capacitor yet. So we should not have gone full EV. What's the penalty of it? Engineering wise, penalty is your battery has to become huge. So instead of making a normal small size battery that would have been only good enough for 100 kilometers, it would have taken care of 80% of planet's normal four-wheeler communication. Removing taxi, even taxis most of the time would be covered, because again, on paper 100 kilometers sounds very small, but you have to realize we live in a world which has traffic. So you're not moving like, swing, swing, swing. Like, for example, my January expo, Delhi expo was here, and my hotel was here. That's 22 kilometers, not that far. It took 2 hours. And again, the same story goes in New York, same story goes in Tokyo, same story goes in Mumbai, same story goes in like any populated city. That's the reality of it. And nobody is like, you know what, I like wake up in 1 a.m. and then I carry my child to school that is like 200 kilometers away. That's not happening. So distance wise, you do not need ginormous battery, but because you meant battery only, that was the only way we can do to have a huge battery. So bigger the battery, huge the basically weight and penalty, it's far more costly. And again, it makes fast charging necessary. This is where it backfired. Bigger battery, okay, you can deal with it. It's just that the moment you have to touch fast charging, it backfires. Because again, fast charging is expensive on both ends. Now, here's the deal. Why is that? Why fast charging is a detriment to technology and everybody is hell-bent on this? Well, that's the reason why EV has not become a normal thing. If you compare EV fuel efficiency or energy efficiency, you have to utilize a unit known as kilometers per unit, aka kilowatt hour. So a normal electric vehicle, let's just say Tesla Model X, will give you 4.4 kilometers. And Hyundai Ion, that's very good, a very lightweight, efficient car, 5.8. Really badly designed one, Audi e-tron, this puppy only gives you 3.5. Now, how good these numbers are versus how bad they are? Well, if you compare that to fuel counterparts, basically, let's say Audi A4, that puppy gives you 1.6. Now, like, wait a minute, that has fuel. Yeah, fuel has energy content that can be classified as kilowatt hour. So we can calculate it. So you can see there is a 3 to 4x efficiency gain when we went from combustion to this. Lot of things are playing a role, not only the ludicrously high efficiency of charges going from battery to actual motor, and this whole pipeline is super efficient, and motor actually converting it into useful system, and the fact that we do not have gearbox, we do not have clutches. So all of those things pile up. That's why this efficiency is so high. Although it does go down if you make bigger battery, which again, that's why I said bigger and huge battery. Look into the battery size of e-tron. E-tron has bonkersly large size battery for such a tiny range, because again, it's not efficient. So what does this mean to you and I? To you and I, all it means, we must use cheap electricity. If we use expensive electricity, we might as well use fuel. Let that be very clear. That's the whole point of the electric vehicle, right? You buy it, it's cheap to run. If it's like expensive to run, then what the hell? So you gives a 3 to 4x differential. Let's just call it 3.5, call it average. So to give you a context, in India, home electricity is around 3 rupees to 8 rupees. Again, focus on the numbers, do not focus on the units. 3 to 8 per kilowatt hour. Now, if you do AC fast charging, DC fast charging, the moment you swipe your card there, credit card, debit card, or whatever have you, the moment you swipe, that puppy is charging you 15 to 30 rupees per unit of electricity. That is same price. Basically, your price went so high that is like you might as well be just consuming fuel, and you have no other option. The moment you go long distance, you have to rely on fast charging. There is no other option. So you reached a point where its circle is complete. And again, Tesla was very smart, that they knew that people, if they wanted to sell people on this bad idea of like full EV, they made sure that everybody has the charger, and then they made sure that it's free for first few years. The moment people start, wait a minute, why it's costing so much? Yeah, that's expensive. Why it's expensive? Like, what's fundamentally there? Well, you have to understand, whenever you're talking about AC level 1, AC level 2, they are AC charging. The charger is in your car, what we call onboard charger. So that's a very low power unit. That could be as low as 5 kilowatt, as high as 22. That's the upper limit. And AC level 1 simply means single phase. AC level 2 means multi-phase. Now we call it multi-phase because of USA. It has a butterfly phase, 180 degree apart. And most of the place like European Union, India, and China, it simply means 3-phase. So multi-phase is AC level 2. And what these things are, they are hollow, most of them. All they have is a microcontroller that screams at the car. It's like, bro, my rating is 7 kilowatt. Do not draw more than that. Have a contactor. Normal thing which we have for, well, everything. Every motor, a giant motor generally runs on contactor. So we good. We got that 3-phase contactor. Take it and go. And some safety fuse and some current measuring circuitry. So all it does, screams, bro, this much. Okay. Contactor energized. Energy goes. Charging is done by your car. So whenever you buy the car, you have already paid for the charger. The moment you come to DC system requires bonkersly large amount of that onboard charger stacked. This was another genius of Tesla, was like, hey, we have to put onboard charger into this. What if we bulk order that? So let's just say best case scenario you can get in Europe is 22 kilowatt unit, and they can fast charge at 200 kilowatts. So where the heck that power is coming from? They are not coming from anywhere. They're just taking that, stacking 10, 20 of them. So whenever you see what is that fast charging, it's that brick box. So there will be a transformer box, and then there will be converter box. That converter box is just that onboard charger, boatload of them. So they are stacking it like servers, and that's how they are running it. And you can understand that price went stupid. It's not expensive, it's stupid. So the moment you look into the basically the price breakdown of why the unit cost is expensive, first you have to understand, anyone doing this, they will only do it if it's profitable. They're not gonna like burn money away. You can try that, government can try that, but it's not gonna be very viable long term. And now you understand why Elon Musk was so hell-bent on getting that grant for that charging infrastructure. Loan EMIs would be around your 26% of the component. Electricity on demand, and be mindful, you're consuming so much of it. And again, it's a charging spot. You want people to use them. So you will be scaling your system for a lot of traffic, so to say, like at least few cars per day. So, and again, that's way too low, but let's just say you are aiming for that. So electricity, demand fees and all that would be there. Then you will have some staff or tools and this charger, because again, these are super expensive devices. They have warranty period. Warranty period is generally, best case scenario is 10 years. You have to make sure that you basically do ROI on those puppies at 8 years or 5 years, meaning your unit cost is very high. And not to mention commercial electricity is also expensive. That's why once you add up all these things, it becomes so expensive that if you have to pay fast charging price, true price, not even like even after subsidy, it becomes so expensive. It's like, might as well use fuel. Be mindful, fuel prices are subject to a lot of politics, subject to a lot of tariffs. Same goes with electricity. So you could be in a scenario where it's like electricity is so cheap that even with this fast charging tariff, it's like not that bad. But most places it's not that bad, including Germany, it's not that bad. And fuel is actually cheap. Like a lot of country put a lot of effort into making sure that fuel is cheap. So it's a really tough pill to swallow. And again, you on normal system where you just like plug it at your home, you did this. Now prices are very high. So all the efficiency gain is lost, and at that point in time, might as well use a normal, cheaper car. So that's why TCO starting to hit people where it hurts, their pockets. Now we come to the core delusion aspect of it. Now be mindful, this is the experience of people who bought it from, let's say, 2005, or let's just say even 2010. or even 2015. Damn, I'm old. Basically, no one likes to pay for more, pay for the same thing more, right? It's like, oh, I'm paying 2x the price, I'm getting the same thing. Nobody likes to do that. Nobody hates their money. It's like, yeah, no. So that's the first bitch slap. Second is, it has low to zero, resale value. Look into the people like actually analyzing the what is the resale value of Cybertruck. It's like, damn. So yeah, that's not good. And the penalty is that it's, why do you have to worry about resale? Just use it. Yeah, the resale is so low because the lifespan is limited. And again, that happened to the people who were the first purchase. So it was not like a polished iPhone experience. It was like, yeah, risk it. And because it was no hybrid system to fall back onto, and everybody jumped into this full battery system, yeah, poor lifespan made it really, really bitter. And here's the deal. Ask yourself, who would you trust? Someone who actually owned an electric vehicle. He was very happy in the first few years, and then he realized it was how terrible of a deal it was and how poor he became because of that. And if he tells you that, hey, you saw me using it, I'm not buying my second car is not an electric car simply because of this bad experience, versus look into this influencer saying this electric vehicle is so awesome. And be mindful, majority of the vehicles are solely there because of subsidies, production infrastructure, and again, charging infrastructure also. The moment you remove that, most companies don't even have a plan of how the heck they're gonna pay it off. Like it's not there. It's just like government give us money. It's almost like the silliest one I have seen is like US government giving money to telecommunications to like, hey, can you please put fiber everywhere? Companies are like, yeah, give us money. It's like, what happened to the money? We ate the money. Give us more money. It's like, what about the fiber? Lol. So same thing is happening here. Every country, be it China, be it Japan, be it India, be it USA, it's the same thing. It's like the moment you remove subsidies, the price, especially fast charging equipments, is like, yeah, no, just like no. And the system is flat out not sustainable and long-term viable, and astronomical repair cost. Now let that be very clear. People was sold this idea that electric vehicle are like, very low maintenance. That is absolutely true. You do not have to change oils and all that. That's very good and true. It's just that the moment you have even a minor accident, compared, like we can drive ice in this sort of condition, you have any minor addition, high voltage battery will disconnect, and you're like, lol. Like, I'm not even joking. Like, every EV is so finicky that you're like, done. Like, it bricks itself way too quickly. And again, people are coming from these sort of tank units, and I'm not even comparing trucks. Half the trucks that are in Indian roads and Pakistani roads, they look like freaking skeleton, and they're like, yeah, we good, bro, we good, we can keep giving you service for next 20 years. And many of them are 50 years old. So that's why that delusion is like so painful for people. It's like, wait a minute, I'm paying double or sometimes more than that for the same equipment. I'm literally getting no resale value or almost negligible resale value. And it's not something that like where I can actually use it for very long duration, because again, batteries will poop out. And without subsidy, basically the moment government gives up on this and like shut down the subsidies, yeah, this thing will become a brick. So, and astronomical, again, if nothing bad happens to you, awesome, have fun. The moment even minor incidents happen, which again, you live in reality, things happen, yeah, it's so bad. In some scenarios, people use dynamite to boom their cars just in anger. Now, so far so bad, but is there a solution? Thankfully, yes, there is a solution. We basically need time for the grid to grow, because here's the deal. Whenever you're talking about fast charging, people are not fundamentally understanding. Whenever you're talking about normal power system, they're generally stepping it down from 11 kV to 220 volts in India. You could have like, I think 8 or 9 kV in USA and dropping it down to 2 phases of 208 volt, basically 1818 butterfly transformer. So that's a super simple thing. Easy peasy, not too expensive. The moment you start talking about like, we're gonna have 100 kilowatt, 400 kilowatt, and again, multiple cars doing that, that's multi-megawatt. Yeah, 11 kV can no longer do that. You literally have to go to substation, put power lines from there, and that would be high tension power line. That would be 33 kV minimum. And the moment people start smoking Elon Musk and they're like, yeah, Elon weed, it's like, yeah, I'm gonna do multi-megawatt charging on trucks. Yeah, that's a 135 kV line. You do not want to Google the price of 135 kV transformer. Everything else will look free. Oh, and by the way, those transformers are not mass-produced items. So even if you want to open it, you may have to place an order 2 years in advance so you get the transformer on the right time. You basically would need a substation that drives a small block or basically whole giant megapolis building. or multiple small villages. That's how much power we are talking about. So that's why fast charging is not just logical, it's idiotic. So you need to grid to expand. Why would grid expand? Because renewable is happening. Again, everybody is doing solar and wind, not because of environment, because it's economical. Heck, I have 2 kilowatt system. One of my basically neighbor has 10 or 22 kilowatt unit, and it's not government subsidy based. Why? Well, power is very bad here. Like power just came right now. So power is really bad here. So again, what's the solution? Have solar, remove that electrical expenditure, and have better quality of life. People are doing it on their own. So renewable is logical right now, economical. And again, people do say some bitter things about solar in USA, and it's not because of solar penalty, it's because you have too much bureaucracy. You should work on that rather than the solar bad. No, solar good, it's just that you have too much bureaucracy. It should not take you years to get the permit. It's like, what the hell? So renewable is doing that. So renewable is pushing grid everywhere, spreading it out, expanding it, making sure that you can have energy lines. And energy lines are so expensive. Elon Musk, Boca Chica, Star Factory, that Starship Factory had an issue. It's like they have to buy a lot of oxygen and a lot of nitrogen. Here's the deal: there is no production of these things. We just condense air and then separate it and ship it to you. Now, shipping it to you makes sense if you are buying a small amount, let's say like hospital and some industrial system. Elon Musk is drinking those things. So it makes logical sense that you should have your own air distillation system. So why don't they? Yeah, they did not have basically power line. So first they're like, okay, we're going to do that. Then they're like, okay, we have a sealed oil well that has some sort of gas pressure. We can use that. They tried, it did not work. Then put like giant enormous solar panel, did not work. Finally, and again, they did that from day one, but permit and bureaucracy took so long before they can have high voltage lines going there. And they buried it. That's why you don't see it in footage. They buried it, which is triple the cost. And and I think in next year, you should start to see air distillation on site. If it is that expensive for that, and you are just saying, oh, we're going to have in middle of nowhere, we're just going to have a truck megawatt charger. Yeah, no. I'm not even calculating the cost of that. At that point in time, running it on premium gas would be cheap. So fundamentally, you have to let renewables expand the grid, not yourself. Like if you push EV to expand the grid, yeah, it's backfiring. Because again, somebody has to pay for the EV. Electricity comes from renewable. EV consumes electricity. You do not want the consumer to pay for something. You want the producer to be like, hey, I'm paying because again, I'm making profit of it. So what should we do with vehicles? Well, simple. Series hybrid range extender or PHEV, plug-in hybrid vehicle. So these three things are the same thing. The idea is you never have sole battery electric vehicle, meaning you shrink the battery. You're just like, okay, battery, instead of let's say 75 unit battery, you just shrink it down to let's say 40 unit battery. So cost goes down, weight goes down, and yes, engines are very lightweight, very small, and especially if you want to use it as a range extender, it could be even more lightweight because again, you do not know variable valve timing. You can make it far more efficient. It will be efficient while it's running simply because it's running as a base load. It's not fluctuating. All the energy is going into battery. Battery is feeding the motors. And if motor needs more, battery drains more. If motor is not consumed, battery charges more. So you get far higher efficiency because of series hybrid topology. So and this allows us to change our thinking perspective. We have to let go of this idea of like petrol pump or a gas station. You go there and you feel that idea is bad. So we have to do something like this. I'm ashamed that freaking UK people figured it out. This is an electric pole and they have a charger there. And you can see this is a very thin cable. Yeah, because it's AC and only 22 kilowatts. So not even that many. I'm pretty sure it's not even that high. But you get the point. Like it's so logical. You have electric pole. Small thing just like, and again, electric poles do have 220 volts there. Ta-da! No super giant expensive converters, and again, copper is not worth stealing in these things. Oh, and that cable, it's idiotically expensive when you are talking about DC charger. Why? Well, people did wanted that amp, 100 amps, 400 amps, and I do not want to Google like what is the stupid amps they have achieved with that 10C charging rate. Yeah, so amps are stupid. Here's the problem: copper can only be so thick before it reaches a point where it's like, you have to be Arnold Schwarzenegger to move it. So people came up with a compromise. The compromise, you make the copper as thin as possible and then you liquid cool it. And now they're reaching a point you have to refrigerate it. Only then copper can carry enough current to be useful. Normal cable, man, I take it and go. And it's not even that expensive that it's worth selling. So, and again, what you see there is just a spool mechanism. It's not actually this big. That big green box is not even that big. The contactors are this size. And again, this is what we're supposed to do. This is what you're supposed to have in your parking areas, especially for office parking. Why? Well, double benefit. First, every country is putting a lot of solar. Penalty, we create overproduction in daytime. How about You charge your vehicle at daytime. So you do not have to like, okay, let's say my EV has range of only 100 kilometer. I go to office and office is 22 kilometer and I have to take a detour. I will be out of charge. No, 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 sir. You come into your office, you're going to stay there for hours, plug it in, relax, chillax, have fun. And again, the excess solar production will be consumed by your battery. It's like, we good, bro. We good. We got this. Overnight, you're going to sleep for 4 to 6 hours, plug it in, forget about it. So we have to change our habit. That time, that changing of habit can happen because of Series I. And most of the time, this will be taken care of. Like, hey, charging in office, charging in house, done, go home, sweet dreams. And never invest billions of dollars into these things. I'm not even joking, $2 to $3 billion have been burnt into this. So never worry about these things. And when you do need to travel for long distance work, for my court case, I have to travel freaking 220 kilometers one way. That time is like, it's just a fuel car, which is extra efficient because it's staying at BSFC island rather than like wandering off because of road conditions. So more efficient. So basically you're supposed to charge at daytime, or you charge supposed to at night at home time. Basically when is the downtime. And another aspect is the moment you do it with trucks, that's a series hybrid system. If you can find the charger, a low watt charger, cool, awesome. Any reduction on this sort of system is priceless. How priceless? Mathematically, you're talking about if you reduce the fuel consumption by 10% only 10%, that's like removing one car from the street. That's another reason. More and more truck we are using, that's why the fuel line is going up. So that's why it's not plateauing. We have to, it's keep going up. So we have to make these things more efficient. So even if you can make them efficient just by using series topology by 10%, it's shut up, take money. And you made it 20% efficient, or have a scenario where you can charge the battery slowly overnight. Like not every truck is like 24 into 7 into 365. A lot of trucks are like, short haul trucks. Those can be done. And you never have to like, oh, I forgot about charging, now I'm stuck. No, start the engine, have fun. So that's a very good thing. And China did something very clever. Again, they knew fast charging will destroy everything. So they're like, hey, what if we have this place where you have a mine and you have trucks, big dump trucks going back and forth from mines to a railway station. It's a fixed system. And they have a lot of trucks going back and forth. It's like, hey, what if we have battery swapping? And they slow charge the battery in 4 or 5 hours, and they have multiple batteries. So there is always a fresh battery ready to go. And because it's a fleet system, internally locked system, it works. They're cool, they're fun, they're awesome. So there is a solution. Like this should be everywhere. This should be everywhere, especially in office, especially if there is underground parking. This should be shut up, take money. We should never ever go for this. This is bankruptcy fuel. And again, make sure we convert our diesel systems into series hybrid. And again, even if you do not have charging infrastructure, they still will save 10%. That is shut up, take money. So there is a solution. We just have to be wise about it. Do not have a premature technology forcing itself into like, I am just as mature and repaired and robust as 105 years of technology of internal combustion engine. That's dumb. So this was my presentation, why fast charging is causing such a brutal penalty for EV penetration. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.